Hello students, next we will look into the robotic drive systems and actuators. What is actuator? Actuators are those components in a robotic system that produce the movement. Link and joint basically help in giving the correct direction, but what gives the power to the joint to move are basically a actuator, just like a motor. Okay, the actuators are powered by the drive systems. So actuators are the basic muscles of the robot which help the robot to move. And whenever we are selecting any actuator for any of the robotic application, we have to consider some of the things, whether it has enough power, not just to accelerate but also to decelerate, so that it stops, we are able to stop the motor. So acceleration and deceleration both should be available. And similarly, if it is able to carry that much of load, that also we have to see if it is able to carry that much load. At the same time, it should not be very heavy. That means it should be light, should not be very costly, that is economical. It should be economical. It should be accurate, so that we are able to do it very accurately. We are able to move it very accurately. We are able to place things very accurately. And then responsive. Responsive means whenever we are giving a command, the actuator system should be very quickly able to do it. At the same time, it should be reliable and very easy to maintain. And there are mainly three types of actuators: hydraulic, pneumatic, and electric. The hydraulic actuators are basically working on compressed fluid or liquids, whereas pneumatic actuators are working on compressed gas, and electric motors, you all know, work on the electrical energy. And some of the motors that we will be interested is servo motor, stepper motor, DC motor, then direct drive electric motors, and all those things we are interested to read about electric motors. Nowadays, what you will find in companies or in applications of robotics, it's mostly electric motors, but heavy industries still use hydraulic actuators and pneumatic actuators. What is the biggest reason? The biggest reason is the power that is given by both hydraulics and pneumatic, out of which hydraulics offers very high power. See, if you take the case of a JCB, the JCB is basically powered by hydraulic actuators, but it has its disadvantage also. That is all what we are going to discuss. Now when we talk about a actuating system, we have to look at some of the characteristics that we have to always take care when we are selecting an actuator. One is, what is the weight? Okay, now as I told you, hydraulic actuators use liquid, so it is having the highest weight, then followed by pneumatic actuators which use gas. And electric motors are also heavy, but not as heavy as pneumatic and actuators, because here we use copper winding. Okay, now other than weight, we are interested to talk about the power to weight ratio. What is power to weight ratio? Is because weight and power are a bargain. Obviously, if you use higher or more components, you will have higher power, but then the weight has increased. So the ratio of power and height, if we are taking, and if we find out that any system is having good power to height ratio, then that can be used for certain applications. Now you can have either the power very high, because of which the weight is also high, so you are having a very high power to weight ratio. Or it can also occur that the power is high and the weight is less, that is even higher power, but we don't have such a scenario. Or you can have low power and somewhat considerable weight, because of which again the power to weight ratio is good, but it is not that high. In electrical system, the weight is less and the power is also little bit, not as much as the hydraulics one. So the power to weight ratio is very crucial when we select for different applications. The hydraulics offers the highest power to weight ratio. Now, pneumatics offer smaller power to weight ratio. Out of the electric motors, the stepper motor is having higher weight. So, generally, what we can see is that the stepper motors are generally heavier, and so for same power, the power to weight ratio of stepper motor is less. Okay, the pneumatic systems offer the least power to weight ratio, so it is used for very applications which require a very soft touch mostly, but still there is a good high power that can be offered with the help of pneumatic systems. Okay, now if you look at the range, then the range of hydraulics systems power is basically 55 psi to 5000 psi, very large. Whereas for pneumatics, it is 100 to 120 psi. Okay, so based on the range and based on our requirement, we can select. Next, we have to study what is stiffness and compliance. See, stiffness is how much resistance is offered by the body when you try to deform it. That is the stiffness. If a body is stiff, you will have to apply a lot of pressure to deform it. What is compliance? What is compliance? Compliance is the opposite of stiffness. Compliance is whenever any force is given and changes are made according to the force applied. So if the object or if the material is easily deformed, then we say that its compliance is good, but its stiffness is not very good. So there is always a bargain between materials, whether they are stiff and whether they are compliant. Generally, if it is very stiff, the compliance is very, very low. And if the compliance is very high, the stiffness is very, very low. Now, why are we discussing stiffness and compliance? Is because in hydraulics, we are having within a cylinder a piston kind of arrangement, and there is oil or fluid underneath it, and then we are having some outlet. Okay, and here let us say that within this outlet there is some or let me draw it little bit in a better way. Imagine this kind of a cylindrical setup wherein there is oil, and then there are two diameters and there are two pistons. One piston is here and another piston is here. Basically, the hydraulic system works in this way that the diameter is different, or the surface area here is different from the surface area here. So here, whatever is the pressure you are applying, that pressure is getting multiplied, and it reaches here, the other side. Anyway, there is fluid in between. Okay, and this fluid is stiff. Now, what is the meaning of stiffness? Stiffness means it does not deform easily. Stiffness is how much it is able to resist. So here, when you are trying to press down the piston, it is not easy to deform. So because of the stiffness, you will have an equivalent kind of movement here. Equivalent, when I say, you have to take care that the area is different. But whatever is the we are applying, based on that we are having the movement because it is stiff. Now, instead of this, if suppose there is air here, instead of this it is air, then we will call it as a pneumatic system. Pneumatic system. And what happens in a pneumatic system is, even though we press it, there is some compression of the air molecules. So here, even though there is movement, it is not as accurate as it should have been. Why? Because some of the air gets compressed. So air is more compliant, or gas is more compliant and less stiff, whereas fluid is more stiff and less compliant. That's why the pressure that is there for hydraulics is very large, whereas for pneumatic is not very large. At the same time, because of this only, the hydraulic systems are more accurate and the pneumatic systems are not very accurate, because of some compression of the air molecules here, the movement is not very accurate. Okay, so stiffness and compliance is something that we have to always look into. Next, let us look at the various factors of hydraulic, electric and pneumatic systems. The plus sign that you see here are all the positives or the advantages, whereas the negatives that you see are basically the disadvantages. So for each we have written various points. Now what you have to remember here is, based on the marks you have to expand upon this, and it's not very difficult. Okay. Now it is good for, hydraulics are good for large robots and heavy payload. You have to lift cars, if you have to lift heavy machinery, then hydraulic systems are better for robotics as actuators. And hydraulics have the highest power to weight ratio, and because the system is very stiff, it has high accuracy and better response. That means it responds very fast. And we did not have any gear system for controlling it. We can just control it by the area. Okay, so there is no reduction gear needed, so the gear system is avoided. But you might think that okay, gear system is required. Yes, we require gear system, but we have something in hydraulics that is better than the gear system, and it can work in a wide range of speeds without difficulty. Okay, which one? Hydraulics. And whichever is the position you are having, you can fix it in that position and you can leave it without spending much of power. For example, you have seen a JCB. JCB basically works in hydraulic system. So if JCB has lifted something up, then it can remain in that position for a very long time. So for maintaining that position, it does not require much of power, hydraulic systems. Okay. What are the negatives? The negatives is that it may leak and not fit for clean room application because it's oil. And because the fluid is there, you require pump to pump it from the reservoir. Reservoir is where you store the oil, and for the pump to operate you require motor and pipe systems or hoses. Okay. Another disadvantage is that it is very expensive and noisy. Why? Because of this pump, and it requires a lot of maintenance. Another disadvantage is that the oil that you are using, its viscosity will change after some time when the oil heats up. So the accuracy again gets affected. And because it is oil, it is very susceptible to dirt and other foreign materials that may go into the oil, and then your system may not work properly. Hydraulic systems are having very low compliance. That means it is not very easy to use, and the power that we are using or the high torque that we are using is really high. So we cannot use it for very low applications. Okay. Next, let us look at the pneumatic systems. Okay, pneumatic systems. The good thing is that most of the components are readily available off the shelf, and they are very reliable components. And because there is no oil and not electricity is used for working it, it has no leak or sparks. Okay, it is generally inexpensive and simple. The systems are very simple. And as far as hydraulics is concerned, this operates at a lower pressure. Okay, lower pressure. but obviously because of which the power it delivers is not that good, but it offers or it works in low pressure. Okay, and it is very good for applications which require rapid on and off and pick and place, and the system is very compliant. Okay, what are the issues? Again, here you have this pump for pumping the air, so because of which it is very noisy system. Okay, and whenever you are talking about air, the air's pressure has to be maintained, the clean air has to be given, so filter has to be used. So all these are the negatives. Similarly, because they are compliant, it's not very useful for linear position control because you cannot control it very easily, pneumatic systems. And similarly, when the load is there, okay, when you are trying to lift some load, the pneumatic system may deform. System may deform means the air may get compressed and we will not get as accuracy as much as we want. Okay, that is this inaccurate response, that leads to inaccurate response. And pneumatic system has the lowest power to weight ratio, that means the power is less but the weight is very large, so the power to weight ratio is less. The third is the electric systems. The very good thing about electric systems is that it can be used in all robot sizes. If you are having small robot, if you are having big medium robot, you can have electric actuators, and it is very very good for high precision robots because you have very good control, because it is controlled using current. Okay, and it has better compliance than hydraulics, and even though the power that is there, you can use the reduction gears. Okay, you can use the reduction gears for controlling the speed. Okay, the very good thing is that you can use it in clean room applications as it does not leak. It is reliable and require very low maintenance. Electric motors require very low maintenance. Now initially there used to be this problem of sparks generated in electrical motors, but nowadays we can have it as spark free. Nowadays we can have it as spark free. So whenever you are having environment which has lots of gases in it, you can even use electric systems, electric motors, because now there is no spark generated when you are running an electric motor. Okay, what are the negatives? The negatives is that it has low stiffness. Low stiffness means you might have seen, if you are using a very small motor, or you might have used toy car, if it is battery operated, you can stop the wheels of a running toy car with your hands. Why? Because because the battery is not providing power? No, the battery is providing power, but because you have hold the tire of the motor or the tire of the car which is run by the motor, you are basically hold on to the shaft of the motor. So if you are having a motor and there is a shaft, if it's not a very powerful motor, you can just catch this particular shaft of the motor and the motor will stop rotating. Okay, so because of which we say that it is having low stiffness. Okay, it gets deformed. What gets deformed? The magnetic field which rotates the motor, that gets deformed. So that is why the motor slips. Electric motor, if too much of pressure is applied, it does not run. For example, you might have seen in your home when you are using mixie, sometimes if you overstuff the mixie does not work. It might be rotating, the motor might be rotating, but the shaft will not rotate. Okay, why? Because it is slipping. Then whatever is the reduction gear that we had used, see here we had used the reduction gear to reduce the inertia on the motor, whereas here we are talking about the reduction gear to be used for reducing the speed. But when you are using a gearbox, obviously the cost and the weight goes high. Similarly, for the motor, we need a kind of braking device which will stop the motor very fast. Okay, so these are the advantages and disadvantages of each of the actuators. Thank you.